When Cisco designed ACI, they realized that there was a gap between the way that the network folks talked and the way that the application folks talked. And so the network is actually in place to host all the applications. And if we could translate the application requirements into network requirements, it would be much easier to understand for not only the network group, but the application group and the security group and the server group and all the other groups we need to collaborate with on a day-to-day basis. So we looked around at the different types of administration that we do today in IT, and we found out that if we had to do it all over again, the way that we would configure our network would be based on groups. For instance, I may take my network and divide it up into groups of devices. And I would say, for instance, that my web servers need to talk to my application servers. Now, I've just created two groups. I've created a group called web servers and a group called application servers. And sure enough, I have a 3-tier application, so I'm going to create another group called database servers. And when I look at how they need to talk to each other, that can very easily be defined. For instance, people coming from the outside should only be talking to my web server over port 80 and 443. Now, ACI is built on something called a whitelist fabric, or a zero trust fabric, which means nothing can talk to anything else until we allow it to. That's different than a traditional network, where if my port's turned on and I plug in, I can actually start routing or switching to other devices on the network. In this case, I can't get anywhere until I first define a policy that says that this group is allowed to talk to this other group. So in the case where I have users from the outside that need to talk to my web server, I would use something called a contract. And a contract controls how one set of devices or group of devices would talk to another. In this case, I could say that people coming from the outside would need a contract that allows port 80 and 443. And they're only allowed to talk to my web servers. They're not allowed to connect to my app servers, and they're not allowed to talk to my database servers. So by doing this, I've created a much more secure network in the fact that people can come to the outside and they can talk to my web servers over the ports that I define, but they're only allowed to talk on 80 and 443, and the rest of my traffic will be dropped. I can also say that all this traffic should be inspected by a firewall or go through a load balancer. And that's that first box you see in the bottom left, where in my contract I can say only allow traffic on ports 80 and 443, and by the way, it needs to go through a load balancer and a firewall before it gets to the web server. I can then say that only my web servers are allowed to talk to my app servers, and that as well has to go through a load balancer. From that point, I can say that my app servers are only allowed to talk to my database servers, and they're only allowed to do it over certain ports, but it doesn't need to be inspected by a firewall because I've already gone through several layers of layer 4 through 7 services. So this actually directly maps to our application requirements, as well as the fact that it makes the network very easy to configure, and on top of that, it's much more secure because I'm only allowing my end users to talk to my web devices, and I'm only allowing my web devices to talk to my app devices and my app to my DB. Web can't go directly to DB, app can't go directly to my end users. All those security issues are actually handled for me by using these whitelist policies. And if I can use these whitelist policies, I've actually reduced the attack surface inside my data center by as much as 80%. So you can see how powerful this is. I have the capability to segment workloads in my environment any way I want to. I could start very simple and say VLAN 1 is only allowed to talk to VLAN 2, or these VLANs are allowed to talk to each other. I could say my production network's only allowed to talk to my DMZ over certain ports and vice versa. I can divide up my application tiers in web, app, and DB and control how they talk to each other. I can also get very granular with how I divide up these workloads. I could say a certain set of IP addresses belongs to this group. I could say this one IP address belongs to this group. I could say that, based on the operating system, if this is a virtual workload, that it goes in this group. Or based on the name of the device, it goes in this group. I can also say that devices within the same group aren't allowed to talk to each other. So I have a ton of flexibility with how my devices talk to each other, as well as how much security I want to apply at each layer. This is game-changing in how we do networking. Not only that, but I can take that policy, define that policy once on an application-by-application basis or on a VLAN-by-VLAN basis, and then I can reuse that known good policy over and over again. And I can push that policy to physical devices. I can push it into different hypervisors. I can apply that policy to layer 4 through 7 devices or across multiple data centers. I can apply policies to IP-based storage traffic and different types of containers and compute nodes. I've got a ton of capabilities now because I've decoupled the devices from their IP address and their VLAN, and I put them into these groups where I can apply policy and reuse known good policy and reduce the amount of human error and apply more security than I ever have been able to in the past. This is a very exciting time for networking. Please join me for our next lesson, 10.4, Examining Contracts, Subjects, and Filters.